Welcome back. Today we're going to be looking at iterators in Python. So what are iterators? Well, iterators are used for looping, and you may recognize this picture as it's been used before. So something that is iterable is something that contains an iterator, and we've already seen these. So we've seen lists, strings, dictionaries, tuples, sets, an IO wrapper, so when you read a file. However, we've probably also seen that the type error int object is not iterable, because if you have an integer and you try looping through it because you forget the range or something, it gives you this type error. So you can't iterate everything. But you can, however, define your own object to be iterable. So what is an iterator? Well, we've already seen for x in iterator, you can do something. So if your iterator is a range object, or a string, or a list, then you can loop through it. However, the alternative is you define your iterator as the iterator of the iterable, and then you put this into, this is a bit confusing, but you say x is the next iterator, and if there is no next, then it returns none. And then this fancy equal sign is saying set x to the value of this, so the next thing in the iterator or nothing. However, if the thing you're setting it to is false, or anything really, then return that. So this just says while the iterator has something that comes next, then you do something with your x value. So we're going to create our own iterable class that loops through prime numbers. So the first thing we want to do is define an isPrime function. I'm just taking a number x and it will return true or false. So we're going to assume that x is an integer, and if x is less than or equal to 1, then it's not prime, so return false. The next thing we want to do is check if it's even. So if x is equal to 2, then we return true, because true is the only even prime. Otherwise, if x mod 2 is equal to 0, and there are other ways of doing this, we could say if not x mod 2, or if 0 XORed with x mod 2, or we could use our bitwise operator and check if the last bit exists by saying x and 1, but I'll leave it as this for now. Then we return true. Otherwise, we want something a bit more complicated. And so what we'll do is we'll start with the number 3, and we'll loop using I. And we want to go up to 1 more than the square root, because then we're going up to the square root. And so for that, we'll actually need to import math. So it's the floor of the square root of x plus 1, and we want to go up to that. However, we also want to step by 2, because we just want to check odd numbers. And yeah, this means there'll be some that we're checking multiple times, but it seems a bit pointless to check if that number is prime and then check if that number divides this number, because that will be a bit slower. And if it is divisible, then so if x mod I is equal to 0, so it's divisible by I, then it's not prime. And I've noticed here this should say false. But otherwise, if we get through all the way through the for loop, then we can return true. So this means it's gone all the way through the for loop, and at any time it hasn't returned false. So we can just test this, and we can print is prime some prime numbers. So I'll print 7 and put in 9. So we can just test these numbers, and we can see that 7 is prime and 9 is not prime. So it works. Okay, so now I want to define an iterator. So we'll have our class and call it a prime iterator. And rather than defining an init method, because it's not going to do anything, we're going to define an iter method. and this isn't going to take in any more arguments, and so we'll set the value equal to 2 because 2 is our first prime, and then with an iterator you return self, and this is the way you do it, so that when you say something is equal to an iterator, the thing you get back is the iterator. So let's try that. So we'll say that our iterator is a prime iterator, and then we'll just print iterator. And we can see that we've got a main prime iterator object and then a memory location. The other method we need to define is a next method. And again, this just takes in self. So we want to say that the value is equal to self.value. And then at the end, we're going to return the value. So this is when we call it the first time, we get 2 rather than a new value. And yeah, maybe we could set it to 1, but this is a good way of doing it. And we can then apply Chebyshev's theorem, which states that between n and 2n there must be a prime number. So we can use a for loop and say for I in range self.value times 2, and then look for primes. But first, it would be useful if we could use this kind of fact that all prime numbers are odd except 2. So we say that if the value is 2, then we set it to 3. Otherwise, we'll put this for loop in, and so we can jump up by 2. And then here we'll say if I is prime, then the value is equal to I, and then we can break because we don't need to keep looking, and then in the end we'll return value, which we set here. So now we actually want to change this so that instead of taking a class, we print the iterable version of this class, and you can see that nothing has changed. And then for a few times we'll print the next iterator, and we'll do this a few times. And you can see that it's gone 2, 3, 3, and that's because we should set this to the value plus 2, so otherwise it's starting at the value and immediately finding out that it's prime, and that looks like it's fixed it. So this is going to go on forever, so we could just say for prime in the iterator, we can just print the prime, and that we can just leave printing prime numbers forever. And because this is Python, we don't have to worry about it eventually reaching a stage where an integer is too big, because Python stores all numbers as big integers, which means it can have an unlimited size. So I could leave that running and generate loads of primes, or probably turn it off. So hopefully you've enjoyed this video, and I'll see you again same time next week. Till then.